Albert Einstein and Sir Isaac Newton are two titans in the world of science, each having transformed our understanding of the universe in profound ways. Their contributions not only pushed the boundaries of knowledge, but also challenged the existing perceptions that governed the scientific community of their times. Einstein, with his wild hair and contemplative gaze, and Newton, the stoic genius cloistered in academic solitude, became icons of scientific thought. Their paths to these monumental insights were as different as their personalities. While Newton's laws came from a world still emerging from medieval thinking, Einstein's ideas catapulted humanity into the complexities of the 20th century. Each man's work reflected the distinct eras they lived in, making their discoveries not just scientific milestones but also historical artifacts that offer a window into the intellectual climates of their respective times. These two figures, though separated by centuries, both dealt with the fundamental forces of nature, yet in strikingly different ways. Newton's universe was one of clocks and predictable orbits, while Einstein's was a fabric warped by mass and energy. The contrast in their discoveries provides a fascinating dual narrative that has captivated scholars, students, and the public alike. Their legacies endure not only in textbooks, but in the very way we perceive everything from an apple falling from a tree to the bending of light around a star. This essay delves deeper into their groundbreaking discoveries, contrasting their approaches and exploring how their work continues to influence modern scientific thought. Albert Einstein, a theoretical physicist born in the late 19th century, revolutionized our understanding of the universe with his theory of relativity. Comprising two parts, special relativity and general relativity, these theories challenged the conventional norms of Newtonian physics. Special relativity introduced the idea that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum is constant, regardless of the speed at which an observer travels. General relativity further expanded this by illustrating how gravity is not a force between masses, as Newton had posited, but rather an effect of the curvature of space-time caused by mass. Einstein's famous equation EMC2 emerged from this framework, suggesting that mass and energy are interchangeable, a concept that has critical implications for both cosmology and technology. His predictions have been confirmed time and again, from the bending of light by gravity observed during solar eclipses to the modern GPS systems that account for gravitational time dilation. The implications of Einstein's theories are vast and varied, affecting not just the realm of theoretical physics but also everyday life. Technologies such as nuclear energy and GPS navigation rely on principles derived from relativity. Moreover, his work laid the groundwork for the development of black hole theory and the Big Bang model of the universe. Einstein's ability to abstractly interpret the unseen forces of the universe has opened up new pathways for understanding the cosmos. Sir Isaac Newton, an English mathematician, physicist, and astronomer, laid the foundations for classical mechanics in the 17th century. His three laws of motion describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. These laws have become a cornerstone of physics, teaching us that an object will remain in its state of motion unless acted upon by a force. That force is the product of mass and acceleration, and that for every action there is an equal and opposite reaction. Building on his laws of motion, Newton formulated the law of universal gravitation, which posits that every point mass attracts every other point mass in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This was groundbreaking as it applied to both celestial and earthly objects. The famous anecdote of the apple falling on his head, whether apocryphal or not, symbolizes the moment of his realization that the same force governing the motion of planets also controls the motion here on Earth. Newton's work in optics, mathematics, and astronomy further underscore his genius, but his laws of motion and gravitation are perhaps his most enduring contributions. They not only provided the tools to solve practical problems, but also offered a new framework for understanding the universe in a systematic and predictable way. Newton's universe was one of order and precision, and it remained the dominant scientific paradigm until the arrival of Einstein's theories in the 20th century. The legacies of Einstein and Newton transcend the boundaries of science, influencing areas ranging from philosophy to engineering. Their theories continue to be the bedrock upon which modern physics is built, and their ideas still fuel the most cutting-edge scientific research. From the hunt for gravitational waves to the quest for a unified theory that reconciles relativity with quantum mechanics, the fingerprints of Einstein and Newton are everywhere in science. Einstein's relativity not only deepened our understanding of the universe, but also expanded our capacity for technological innovation. The principles of relativity underpin the functioning of global positioning systems, which are integral to the navigation technologies used around the world today. Similarly, Newtonian mechanics continue to be essential in fields as diverse as aerospace engineering and biomechanics, proving that Newton's insights into motion and force are as relevant now as they were in the 17th century. Reflecting on their contributions, it is evident that both Einstein and Newton did more than just change the course of science. They altered the way we perceive reality itself. Their curiosity and intellectual bravery pushed humanity to new heights of understanding and capability. As we continue to explore the cosmos and delve into the quantum realm, we stand on the shoulders of these giants, forever indebted to their genius. In conclusion, Einstein and Newton not only reshaped our understanding of the universe, they set the foundations for future generations to dream of the stars. Their work remains a testament to the enduring power of human curiosity and intellect in the relentless pursuit of knowledge.